take a good look at these two numbers and their powers. Which do you think is bigger? Obviously this one, right? Well, if we take 3 to the power of 15, you get 14,348,907. That's big. But what about this number? Something's off. The power is before the number, so it must definitely be lower. But first, why is this number like this in the first place? You see, mathematics has always been a story of patterns, each operation building upon the last in a beautiful hierarchy of repetition. We start with addition, the simplest act of combining quantities. Repeat addition enough times and we get multiplication. Repeat multiplication and we reach exponentiation, one of the most powerful tools in mathematics, which is the process of raising numbers to powers, which is this. But it doesn't stop there. There's an operation that goes beyond exponentiation, an operation so extreme that numbers explode into unimaginable numbers almost instantly. This operation is called tetration.
Tetration is, quite simply, repeated exponentiation. If exponentiation answers the question, what do you get when you multiply a number by itself repeatedly? Tetration asks, what do you get when you raise a number to the power of itself repeatedly? If that sounds wild, it's because it is.
Mathematicians write it as NA. It means taking a number, say 3, and stacking it on itself n times. For example, take 3. Raise it to the power of 3, that's 27. Now raise 3 to the power of that number. The result? 7,625,597,484,987. That's the power of just 3 threes. Add one more 3 to that tower, and your calculator doesn't even try. It has given up. That's how fast tetration grows. Tetration doesn't just grow fast, it grows too fast. Numbers created by tetration are so massive, we can't write them down, can't visualize them, and yet we can define them perfectly. And there's even a number bigger than tetration. Yes, there is an operation bigger than the already unimaginable tetration. This is called pentation. If you repeat exponentiation to get tetration, you repeat tetration to get pentation. And if that's not insane enough, if you repeat pentation, you get hexation. And there's infinitely more layers of operations, each growing faster than your brain can ever imagine. In this hierarchy, tetration is the fourth operation, symbolizing a critical turning point where numbers begin to transcend ordinary understanding. But then mathematicians began to ask a question that changed everything. What if we didn't stop at whole numbers? What if we could have half a tower? What would that even mean? How do you take half of an infinite stack of exponents? That question opened a whole new field of study, exploring how to define tetration for fractional heights. It led deep into advanced math, involving infinite limits, complex functions, and something called functional iteration. It's just math, but on God mode. Thank God they don't teach this at school.